Hello, everyone, and welcome back to our virtual classroom and to our course and to our week 7. Only a few more to go. So week 7, we are going to discuss populations, sample, and sampling. One of my favorite activities, so I really truly hope you enjoy it. And this week we are going to talk about probability and non-probability samples. We are going to do an evaluation of a research sample. And then you're also going to do your research development, your part 4, which is data collection and analysis. So typically when we're looking at experiments or when we're looking at hypothesis testing, we go through a process, right? So we go through an introduction, a literature review to develop our hypothesis. Then we focus on our methodology, how we're going to test our hypothesis, and then one of the most fun aspects is this particular aspect, which is our data collection and analysis. And so, let's go back here. Sorry about that. And then obviously this video will be posted right here under our virtual classroom task, and we will go through each of the steps. And as always throughout the video, I will be providing you with prompts, and that's what you're going to submit as your virtual classroom task. So let's start by downloading our PowerPoint for this week and going through that. So give me a minute here to open that up. And hopefully this will open and we can get started momentarily. There we go. I love this, chips, not fries. So our first order of business is which do you prefer, chips or fries or both? So that is our first assignment. I thought this was excellent. I love fries, but I do love potato chips as well. So I would have to say first would be fries, second would be potato chips, but which are your favorite? So let's start with that. Okay, so let me put this in slideshow mode and hopefully it will start subtitling everything that I'm saying and hopefully that will help. So we are on chapter 9, which is our population, samples, and sampling. And here we have Frito-Lay, the snack food people who bring us Wavy Lay's potato chips, can't check every potato that growers might wish to sell to them. They're about 45,000 pounds in each semi-trailer truck. It would be prohibitively expensive, right, to test each potato and would produce many data errors. So our other order of business is for you to not only choose between chips and fries, but also which brand of Frito-Lay chips are your favorite. I tend to like the Lay's, just plain Lay's. And I usually like those plain Lay's potato chips with some ranch dip or some dressing or something of that sort. So second order of business is to tell us which is your favorite Frito-Lay snack food. All right, so how does Frito-Lay decide whether to accept or reject each truckload of potatoes? Right, the inspector in Frito-Lay's receiving department takes 5 samples, 150 pounds, of the potatoes from each truck to determine whether the entire truckload meets the company standards. So how can the results from so few potatoes, 150 pounds, be generalized to so many potatoes, 45,000 pounds? So this is an example of the sampling of potatoes. However, the question also applies to sampling people, although the reasons differ. So another part of your assignment is how can the results from so few potatoes, 150 pounds, generalize to so many potatoes, 45,000 pounds. And typically when we're doing this, we're hoping for a representative sample, right? We're hoping that these 30 pounds each or 30 pounds each of the 5 trucks show us what exactly the whole population is. And another point to keep in mind is that we now have continuous sampling. So especially in financial accounting or in accounting or in auditing where you're actually sampling the entire population. So data analytics software and a lot more computing power have allowed us to not only have to do sampling, but that we can test the entire population. And in forensic accounting investigations or fraud examinations, that is typically what we do. So the third part of your assignment is to answer that question. How can the results from so few potatoes, 150 pounds, generalize to so many potatoes, 45,000 pounds? So nearly all surveys are based on samples rather than on a consensus. Why do you think that is? So that's another aspect of this assignment that you're going to produce. So we have whether you like fries or chips, what's your favorite Frito-Lay chip? And now our question from the previous slide, and now here, nearly all surveys are based on samples rather than on a consensus. Why? Because typically it's prohibitive, right? It's too much money to have everybody, to be able to access everyone and talk to everyone or have them complete a survey. So consider this, taking a national census is a major operation, right? So in the US, every household in the country must be listed. Every institution that houses people must be identified, whether they're prisons, whether they're nursing homes or mental hospitals, and homeless people who do not live in any dwelling by law must be counted. So can you imagine the endeavor of doing the census? No wonder that we do it every decade and we don't do it every year because of the amount of work that it takes. So next, we have to collect the data, right? We have to computer process it, then distribute it to the individuals, the agencies, and businesses that make use of this census data. So when there are over 308 million entries, every seemingly minor operation truly is a massive undertaking. So think about it now, the population of the US is anywhere from 350 to 375 million people. And that we know that data based on the census, but it's also such an endeavor to try to keep up with all of that information, correct? So in survey research, usually the choice is between selecting a sample and doing no study at all, because money and time costs nearly always rule out a complete count. So that's why nearly all surveys are based on samples, because of typically time and money. And so we don't have an endless amount of time. We all have the same amount of time, and we all have some limitations as to the money, including businesses. So basically, we start off with an example of drawing very small samples from a small population of 6 fish. So the small population size permits listing every possible sample mean of size n, along with the probability of each sample mean. So what we have then, the result is a sampling distribution, a central concept in sampling theory. So sampling distribution is you're going to try to see how your sample is reflective of the population, and you're going to describe your sample through descriptive statistics. So to understand the concept of sampling and distribution, imagine many repeated samples from a population. So you're just going to choose, if there's 6 fish, you might choose 3, and then you might get another 3 and another 3, and you just keep repeating the samples from the population to see what your sampling distribution is. So, of course, real-world studies almost never take more than one sample, but understanding sampling distribution depends on imagining what would happen if repeated samples were taken. So when you're thinking of the concept of sampling distribution, just think of repeated samples, right? You're not always going to get the same 3 fish, for example, in our population of 6. And every time you select a sample, it might be different. And then you're going to see that sampling distribution based on the number of times that you selected your sample. So the 6 beautiful fish example illustrates the tendency of the sample mean to cluster around the population mean. And that helps us introduce the central limit theorem. So one of your assignment options for this virtual classroom is to define the sampling distribution and define the central limit theorem. So provide those definitions, and you can use your textbook as a resource to define sampling distribution and to define the central limit theorem. So the population of 6 fish is flat, but the sample means start to cluster even with a small sample size of 2 or 3. So you're always going to see this clustering, and hopefully everything follows the central limit theorem. So the central limit theorem shows that the distribution of sample means or sums converge into a normal distribution as the sample size increases regardless of the distribution of the population. So what the central limit theorem provides us is it's telling us that our sampling distribution tends to go around a normal distribution. Even though as our sample size increases, we're still it doesn't matter the disbursement or the distribution of the population, we seem to always come up with a normal distribution. So samples can vary. So here's another question to answer in your assignment. So using information from only the sample, how can we know how much our sample differs from its population? So make sure you include this question. So using information from only the sample, how can we know how much our sample differs from its population? Include your answers to this question as well in your assignment for this virtual classroom. So statistical tests, what they do is they apply sampling theory to a practical question. And a statistical test contains 4 main components. We have a null hypothesis. And an example of such is that no relationship between gender and social media use. Then we have a level of significance, and that level of significance is a probability number, and it's usually stated in advance. If the likelihood the null hypothesis is true, it falls below the level of significance, then we reject it. And typically we have a 5% or a 10% or a 1% level of significance. Then we have a p-value, which is a probability number, and it's calculated from the sample. And then we compare the calculated p-value to the level of significance. If it is equal to or less than the level of significance, we can reject the null hypothesis. So what sampling theory provides us is statistical tests. And these statistical tests have 4 main components: a null hypothesis, a level of significance, a p-value, and a calculated p-value that we compare to the level of significance. That's our test. And we usually state the null hypothesis and then the alternative hypothesis. And then we can reject the null and accept the alternative if the p-value that we calculated is equal to or less than the level of significance. So an example, right, when we calculate the mean use of social media by gender, and then we compare the results to the t-distribution. And you'll see figure 4 in your textbook has this particular calculation. So now let's talk about simple random sample, SRS. So a sample from which every possible sample of a given size has the same chance greater than 0 of being selected, and the chance of selecting every element is a constant. So a slip of paper for each of the 30 students drawn from the professor's hat produces a simple random sample. So the key to your simple random sample is that every item in that sample has the same chance, hopefully 1, of getting selected. And that every element is constant, like there's no differentiation. So by putting all of the papers in the hat, you're not looking, you just select one. That is a simple random sample because each item in the sample has the same chance of getting selected. They're all in the hat, and it's consistent and it's constant, right? All 30 pieces of paper are in the hat for the professor to select. Then we have a systematic sample. So here you're going to think of a list of 100 students, let's say alphabetized by their student ID number, and you're going to get a sample of 10 from the list. You're going to choose a random start, 1 through 10, and take every 10th student thereafter. So similarly with a simple random sample, every element of the population has the same chance of selection with systematic sampling. So the key is if you're doing a simple random sample, you're just selecting items haphazardly, whereas in a systematic sample, you're choosing every 10th. And so you're looking at, you're going to start maybe with item number 5, and then you're going to go 10 down, 10 down, 10 down. So then you still have every element of the population, but they all have the same chance of getting selected, even though we are using a systematic sampling approach of selecting every 10th item. So we see the text for why every sample of size n does not have the same chance of selection, because now we're systematically going through it, right? So we know every element has some chance, but it's not all the same, because now once you have your starting point, that's when you're going to come in and look at every 10th item or select every 10th item. So now we're going to look at a stratified sample. So the population is divided into 2 or more groups, which is called a strata, or a stratum to say a singular item. And in that way, that guarantees that each element of the population fits into exactly one stratum. So the text shows you the importance of using sampling weights in calculations that span the stratification variables. For example, you want to estimate the average age or the incidence of cancer in the population. So think of a stratified sample as you're putting items into categories, and those categories are your strata. Then we have a cluster sample. So now the population is divided into groups, but usually it's either geographical divisions, maybe counties or institutions such as schools or businesses. And most major surveys use this clustering sample, right? And so basically you're looking at things that are closely together. So whether they're in a state, whether they're in the US, whether they're in a particular industry like schools, whether they're in a particular business region. So you're kind of creating your sample based off of a cluster, and that cluster is what you want to study and what you want to know more about. Then we have non-probability samples. So here we have quota, snowball, and purposeful samples. There are non-probability, or they're not convenience samples, right? They are likely to contain a bias, and even if they don't, we really have no way to know that they don't have a bias, right? So our generalization from a sample to its population isn't justified, but sometimes we want these non-probability samples because we want to actually know more about that particular population. So a probability sample is nearly impossible to select. So the choice is between no information and some information. So perhaps a lot of information from a non-probability sample might be helpful. So again, we can't have a perfect population testing, so we have to make some concessions and see which type of sampling would be best for our survey instrument or for our experiment, and then see which one applies and hopefully try to eliminate as much bias as we can. So data from a non-probability sample obviously should be considered with caution, but seldom do we reject it as worthless. There is still some informational value that comes from these non-probability samples. Granted, they may have some bias, but there is informational value based on what we're learning and based on the hypotheses that we're testing. So let's review our summary. Before we review our summary, let's go back a second and review the samples, because for your assignment, you're going to select one of your samples. So we talked about the null hypothesis, the level of significance, the p-value, and comparing our p-value to our level of significance to test our hypothesis. Then we discussed all of these samples. So you're going to select one sample type and include that in your assignment and describe it and give an example of it. So you can do a simple random sample where everything has the same chance of being selected and every element is a constant. You can do a systematic sample where you start from a particular point and then select every 7th or 10th or 15th item, as we see here, and then give an example of a systematic sample. So again, you're going to describe a sampling method and you're going to give an example or illustrative example of that sampling method, and not the ones used in this PowerPoint or in our text, a unique one that you've come up with. So it could be a simple random sample, it could be a systematic sample, and then you can also have a stratified sample where you're dividing your population into groups, which is known as strata, and then every item within the population is able to go into one of those stratums. And so you could give an example of that. Then you're also going to discuss, or if you choose to discuss, your clustering sample or your cluster sample, right? You're dividing the population into groups around some type of commonality, whether it's a geographical division or by state or by country or by industry, where you might have schools, where you might have certain types of businesses, retail, merchandising, etc. So again, you're going to discuss the sampling type and then give an illustrative example that you come up with. And then we also have non-probability samples. You might want to describe quotas, or you might want to describe a snowball sample or a purposeful sample. And why do we use these? And then give us, there's still information that we're getting from them. Granted, we do have some bias here, but there is still some information that you're getting from this particular type of non-probability samples. And there's 3 kinds. You may want to describe one of those 3, whether it's a quota, whether it's a snowball, or whether it's a purposeful sample, and then just give an example of that. And that is also part of your assignment for this virtual classroom. All right, so now let's summarize what we've learned in Chapter 9, Populations, Samples, and Sampling. So we started off with a sampling riddle, right? How can the results from one sample provide precise information about the larger population from which it was drawn? So we talked about the 150 pounds sample from each of the 5 trucks, right? And how can that 150 pounds be representative of the 45,000 pounds of potatoes that Frito-Lay is buying from these farmers? And what we use is we're using statistical procedures, right? And we're trying to estimate how close the sample information is to the corresponding population. And that's our statistical inference, right? We're trying to take the sample and we're going to draw some statistical inference to say, okay, if the sample shows that the potatoes are really of the same quality or higher quality, then yes, Frito-Lay would purchase the entire 45,000 pounds of potatoes. So we're using statistical procedures and we're trying to estimate how close the sample information is to the population using statistical inferencing. And then we have sampling distributions, right? And here we're describing how specific sample statistics, like the mean, which is basically your average, right, of like 2 different items within your sample to discuss your population, and how they vary over repeated samples. So the entire sampling distribution of a sample mean and many other statistics can be estimated using only one sample. Typically, when we are conducting our experiments, we only have the opportunity for one sample. We're not able to do repeated sampling and come up with that sampling distribution. So that's where we use our statistical inference to draw upon those. And of course, right, in our real world studies, almost never can we take more than one sample. But if we do understand the sampling distribution, that depends on imagining what would happen if we did have the opportunity to take repeated samples, if we're able to take 5 or 6 or 8 different samples to get that sampling distribution. Great. So that concludes our PowerPoint presentation for Chapter 9, Populations, Sample, and Sampling. And so throughout this video, I kind of went through and told you all of the prompts for your items. So the first for your virtual classroom. So the first was to what is your favorite fries or chips? And then the second was which is your favorite Frito-Lay chip? And then your third is right here. How can the results from so few potatoes, 150 pounds, generalize to so many potatoes, 45,000 pounds? So right there you have the first 3 prompts that we discussed in here. Then we talked about surveys. And then we talked about the sampling distribution, and that definition of the sampling distribution should be part of your assignment for this week 7 virtual classroom. Then we talked about the central limit theorem and normal distribution. So those 2 definitions as well should be part of your submission for the virtual classroom. So you're going to define the central limit theorem and you're going to define the normal distribution, and you can possibly take those directly from your textbook. Just make sure that you are citing your textbook if you're going to do that. Then we talked about the 4 main components of a statistical test, right? So we talked about the null hypothesis and then stating an alternative hypothesis. The level of significance, 0.05, 0.10, or 0.01 are the most common. Then we talked about a p-value, and we're comparing that p-value to the level of significance. And so then we discussed all of those 4 components. And then we talked about different types of sampling. So in these different types of sampling, what you're going to do is you're going to select one type of sampling and describe it, and then give us an illustrative example of it. So you have several options to choose from. You can describe simple random sampling. You can describe systematic sampling. You can describe a stratified sample. You can also describe a clustered sample. And you also have several non-probability samples like quota, snowballs, and purposeful sampling that has some bias, and you can discuss that. And so any one of those you're going to give as an example. So that's the last item that you're going to provide as part of your virtual classroom. So you're going to take one of the sampling types and then give an illustrative example of that. And here is your summary of everything that happened in Chapter 9, Population, Sample, and Sampling. So if we go back into our module in our course, you will see that you're going to submit all of that right here as part of the virtual classroom task. And then we are going to go in briefly here to just review what you're going to do for your discussion. So for this week, we are asking, why is a probability sample preferred over a non-probability sample? And summarize the shortcomings and strengths of these non-probability samples. So that was the last sampling type that we just discussed in your PowerPoint, so that might be helpful. And remember that you have to post your initial response, and then you post at least 2 substantive responses. And again, not just merely agreeing, but also noting, why you agree with the previous student's post, or adding or augmenting or forwarding our discussion in some way, shape, or form is how you can provide a substantive post. And then we have our application assignment where we're actually evaluating a research sample. So you're going to read this journal article, Secrecy and Status, the Social Construction of Forbidden Relationships, and you're going to answer these questions. So you could get that study from our library, and you can possibly even copy and paste it. Let's see if we copy and paste that and see if Google Scholar will get us somewhere. So I just went in and looked for Google Scholar, and then I am going to search for that. And here you see it right away. And you see it's through ProQuest, and that's a database, or JSTOR, and those are databases that we have in our library. So you should be able to find this article here and get that from our library and go through that information here. So you want to read the article and then go back to our application assignment and describe the study participants. Why were these individuals selected? How were initial participants located? What evidence does the author give to suggest that the snowball procedure provided an adequate sample? And how does the author characterize the generalizability of the study? Like, to what population do you think the results generalize to? And make sure you defend your answer. Then you're going to describe the sampling strategy used within the article. And you're going to evaluate the usefulness of that sampling strategy to address the study topic. Like, are there other strategies that might be more useful? Why or why not? Always provide your rationale. And then how did the author decide to end the sampling? Like discuss the pros and cons of the approach that the author undertook in this particular study. So that is your week 7 application assignment, evaluation of a sample. And then our last bit of the assignment is here. We're going to do our part 4, your data collection and analysis. So you're going to consider the topic that you selected that you wanted to research, right? And so you are proposing the topic to an audience that is going to evaluate your research project. So you're going to address each of the following questions below and provide answers to what you would do to prepare your study for a presentation to a particular audience. And we typically do this quite a bit at conferences in the academic world. So here, how did you decide on and start researching your topic? Typically, the topic is of importance to you or you really want to find out more about it. And after you have found relevant information on the topic or research interest, state how you determined that the selected resources are considered scholarly sources. So this is part of our literature review process where you look for double-blind peer-reviewed journals to show that, yes, there is a gap in the literature and that's why we need to study it. And then which research methods would you use in your studies? Like what observations, what examples, would you interview, would you do survey, would you do any type of indirect method or social experiment? And why have you chosen this methodology? What are the strengths and the limitations of that particular research methodology that you chose? There's always limitations and there's always some issues within any study that you do. And then how would you analyze the information that you found in your study? Typically, you're going to do some type of statistical analysis, whether it's regressions, whether it's sequential equation modeling, whether it's multiple regressions, whether it's a time series. So that's how you typically try to analyze the information, is through some type of statistical inference. And then what are some problems that you may come across in your research study? How would you address them? So make sure you're answering all of these within your data collection and analysis. And then if we go back to the modules, then the last item for this week is this virtual classroom right here. This video is posted there, and then make sure you submit as part of this virtual task all of the prompts that I went throughout the video. Thanks for watching.